Good morning, everyone. So, in this video, we are going to discuss about the topic transformer, which is a electrical device. So, first of all, let's discuss what is a transformer. So, as we know, that transformer it transfers the electrical energy from one circuit to another, but the frequency will remain constant, or it will never change the frequency. So it works on the principle of electromagnetic induction. So we can increase the voltage and decrease the voltage. That is step up and step down operation can be done by using this transformer. So for transmission of the electrical energy, distribution, everything, this transformer is very much useful. And without transformer, we cannot transfer the electrical energy. So this is the construction of transformer. Uh, in theoretical study, we are using this schematic for showing the construction of transformer. So as you see, the center portion, the square portion, it is the core, magnetic core of the transformer, and we are having two windings which are wound on the core. So one winding is called as the primary winding, the another one is called as the secondary winding. Always the voltage source will be connected in the primary winding and the load will be connected to the secondary winding. So here you can see capital N1 and N2. So N1 and N2 denotes the number of turns in primary coil and secondary coil. So one denotes primary and two denotes secondary. Similarly, E1 and E2 denotes the EMF in primary winding and EMF in secondary winding. The center we have the dotted line which denotes the flux in the magnetic core. So this is the basic information about the construction. So now you can see the schematic where it shows the physical appearance of a transformer. So the previous diagram, the theoretical study, it helps in the theoretical study, we use that type of schematic, but this is the exact physical appearance of a transformer. So here we are having a transformer tank. Transformer tank, inside the transformer tank only the magnetic core with the windings will be placed. Okay. So as you see in the diagram, it is clear that in the center portion we are having the magnetic core where primary winding and secondary winding are wound. So it is placed inside the transformer tank. So transformer tank will be filled with the transformer oil. So the purpose is cooling. Okay. So in the magnetic core and winding should not get heated much. So in order to avoid overheating, we are using this transformer oil for cooling purpose. So we are having the primary winding, the secondary winding in the core. Then we are having a portion called conservator tank. So through that conservator tank only we are filling the transformer oil inside the main tank. In After the conservator we are having a relay, specifically Buchholz relay for protection of this transformer. Then we are having the breather. Breather, what is the purpose is it will prevent any moisture from entering into the transformer oil. The breather will be filled with the silica gel. So silica gel will absorb all the moisture from entering into the transformer oil. Then next we have bushings, primary bushings and secondary bushings. So where through this bushings only the external connections will be taken out. Okay. So this is about the construction of transformer. So generally we saw what is a transformer and about its construction. Now we can see what all the various types of transformers. So based on different purpose or different features, what are the different types of transformer we are having. So first one, based on the construction, we are having two different types, which is called as core type and shell type transformer. So these are the schematic representation of core type and shell type transformer. So core type and shell type, what is the difference? To see the lamination, the core type is having two L-shaped laminations, where in shell type we are having a V-shaped lamination and then I-shaped lamination. So in core type, the windings are wound around the core, but in shell type, you see in the center limb the windings are placed. So the windings are surrounded by the core. So another important thing is in core type, the copper requirement is high when compared to the shell type. So because of that, lamination requirement also will be high in core type. But when we compare these two, the output will be high in shell type than in core type. The next one, based on their purpose, we are classifying it into step-up transformer and step-down transformer. What is step-up? So it will give a boosted voltage or increased voltage as the output, and step-down it will give a decreased voltage as the output. Then based on the supply, we are classifying it into single phase and three phase transformer. Then based on their use, we are having three different types: power transformer, distribution transformer, and instrument transformer. So power transformer, we are using it in transmission networks, distribution in distribution networks, and instrument transformer as protection. It is mainly for the protective purpose. So instrument transformer, we are having two different types. That's current transformer and potential transformer. So these are the different types of transformers in use. So whatever may be, there will be some losses in any device. So here in transformer also we are having some of the losses. So these are the four different losses which comes in transformer. The first one is iron loss, which is also called as core loss. Then second one is copper loss, and it is also called as I square R loss. And third one is stray loss, and the last one is dielectric loss. So these four are the losses that occurs in transformer. Then efficiency. So how much efficient is a transformer? So how to calculate that? So the transformer, sorry, definition is the output power divided by the input power. That is the definition of efficiency. So the definition is given: efficiency equal to output power divided by input power. So this will give the percentage of efficiency of that a particular transformer. Then what is this all day efficiency? All day the same thing, output power divided by input power, but we are calculating for 24 hours, means for one day. That's why we are given the name as all day efficiency. So when we can achieve maximum efficiency in a transformer? So when the copper loss, WCU denotes the copper loss, WI denotes the iron loss. So when these two losses are equal, we can achieve maximum efficiency in a transformer. So these are some of the basic details regarding transformer. Hope you have understood this. Thank you.